Hello students, by this video let us study about the angular distribution function. What do you mean by angular distribution function? So, previous video we studied about the radial distribution function. So, radial distribution function and angular distribution function both are the two parts of the wave function psi, right? So that we understood that. Okay. So, radial distribution function tells us about the probability of finding the electron maximum around the nucleus. Fine. So that was explained by radial distribution function. Whereas angular distribution function, it also tells about the probability of finding electron around the nucleus at different angles. Okay. So angles, the term angles indicate the angular distribution function. Whereas the term radius indicates the radial distribution function. Okay. So here at a different angles, what is the probability of finding electron around the nucleus? So that is angular distribution function. Okay. So the two angles what we understand here it is f theta and g phi. S g phi. Okay. F theta and g phi. So this also we have seen already while studying about the wave function. So, this angular distribution function, it describes the basic shape of the orbitals or number of lobes present in the orbitals. Angular distribution function, it is depending on azimuthal quantum number L and magnetic quantum number M. Fine? So, now let us study the angular distribution function for oneness orbital. So, oneness orbital. So, what is 1 here? 1 is your principal quantum number L. Then, what is S here? S is the orbital. When the value of L is equal to 0, then it is S orbital. Okay. So, here orbital N, value of N is 1, value of L is equal to 0. Why? Because it is S orbital. In S orbital, the azimuthal quantum number is equal to 0. Okay. Yes. Then magnetic quantum number is also 0. Fine. Now, for this oneness orbital, f theta, that is the angular distribution function f theta is equal to 1 by root 2. 1 by root 2 and the g phi is also another angular distribution function. So it is equal to 1 by root 2 pi. Okay. So angular distribution function is equal to f theta into g phi. Okay. So that is 1 by root 2 into 1 by root 2 pi. So what will you get here? 1 by root 2 into root 2, 2 and root pi. Okay. So 1 by 2 root pi is the angular distribution function. That is, probability of finding electron at these angles is 1 by 2 root pi. Okay. From this value, it is explaining that electron present around the nucleus is independent of direction, does not depend upon the direction. The probability of finding electron around the nucleus, so that does not depend on the direction. Okay. So now for example, if you take a football and hold it and look into it, is there any direction for the ball? No. In any direction when you visualize, look into the ball, you find the same, right? Similarly here also, around the nucleus in the oneness orbital, from any direction, you can find the maximum probability of finding electron. Yes? So, in the case of oneness orbital. Okay. So, now the shape of the oneness orbital is spherical in shape. Okay. So, as the orbital number, that is 1s, 2s, 3s, as it increases, as the s orbital size increases, yes. So, here you can see spherical and still 2s is bit more larger than the first one and the third one is bit more larger than the second one. Okay, as the principal quantum number increases, the size of the orbital also increases, but the shape remains the same. For S orbital, the shape is always spherical in shape. Okay, likewise in this s orbital we can also calculate the number of nodes, right? So in the radial function we already understood to calculate the number of nodes by using the formula n minus l minus 1. Similarly, even here also the angular nodes in the oneness orbital or any orbital we can calculate by particular value. So that value is number of angular nodes can be calculated by L value. What do you mean by L value? L value is azimuthal quantum number. Okay. So when in oneness orbital, what is the value of L? L is equal to 0. L is equal to 0 in the azimuthal in the oneness orbital. L is your azimuthal quantum number, so it is equal to 0 in the oneness orbital. That means there is no nodes in this. There is no angular nodes in this oneness orbital. Okay, whereas in 2s orbital angular nodes are there, in 3s orbital also angular nodes are there. Whereas in oneness orbital angular node is equal to 0. Why is it equal to 0? Because angular node is always equal to L value. Got it? Now in the 2s orbital there are 2 nodes. Okay, 2 angular nodes. Yes, and for 3s orbital there are 3 nodes. So as it goes, the number keep increasing. Okay, so when the value of n is equal to 1, L value is equal to 0. When the value n is equal to 2, then L value is equal to 1, 0, plus 1, 0, minus 1. Like that it goes. So there is a particular formula to calculate it. So all that we have seen already fine. So from now, you just understand in oneness orbital the number of angular node is 0, and in 2s orbital the number of angular node is 2, and in 3s orbital the number of angular node is 3. Fine. Now let us see about the angular distribution in the case of P orbital. Okay. So the value of L for P orbital is 1. Value of L for P orbital is 1. Okay, L is your azimuthal quantum number, and magnetic quantum number value for L is minus 1, 0, plus 1. When the value of L is equal to 1, the magnetic quantum number will be minus 1, 0, plus 1. Okay, so angular distribution function always explains the orientation of the orbitals. Okay, so here because of the value of magnetic quantum number is minus 1, 0, plus 1, what is the orientation? 3 orientations are seen in the case of P orbital. So what are these 3 orientations? They are Px, Py, Pz. Okay, so x, y, z, they are the axis. X axis, y axis and z axis. Okay, so P orbital is oriented in 3 axes. So that is Px, Py, Pz. Understanding? So this orientation is because of the magnetic quantum number value. Magnetic quantum number value. So when the value of L is equal to 1, magnetic quantum number value, 3 values we have, minus 1, 0, plus 1. So corresponding to these 3 values only, we write the 3 orientation. So that is Px, Py, Pz. Fine. So here also we can calculate the angular distribution function by using that formula. But the values is highly complicated. So for that reason we are not going to look into that. We are just studying the 3 orientation of the P orbitals. Okay. Yes. So now let us look here how the shape of this P orbital exists. Okay. So here in the P orbital 2 lobes are seen. The P orbitals are having 2 lobes. Okay. So these 2 lobes, they are either in the x-axis or y-axis or z-axis. So depending upon these lobes, their orientation, depending upon the orientation, Px, if it is Px, the lobes are on the x-axis. If it is Py, the lobes are on the y-axis. If it is Pz, lobes are on the z-axis. So that is represented over here. Okay, so lobes here, the P orbital. So P orbital, the lobe is like dumbbell shape. Dumbbell shape. Yes, so this is the dumbbell shape. So this is dumbbell shape. Okay, whereas in the s orbital, the shape is spherical. Whereas here in the P orbital, the lobes are in the dumbbell shape. Okay, so now here Okay, so it's very simple to draw the diagram. The shape of the orbital is very simple to study. So please, little bit of careful listening is more than sufficient for you to learn this concept. So now I've drawn the px. So how did I draw? I drew the first x-axis, y-axis and z-axis I have drawn. Okay, then the orientation is px. That means the dumbbell-shaped lobe is seen on the x-axis. So you can see on the x-axis I've drawn the dumbbell shape here. Yes. So this is the representation of px orbital. Fine. So in the px orbital, nodal planes. Yes, there is one nodal plane. Nodal plane. So there is one nodal plane. So what is that nodal plane? That is the plane where there is no lobe. That is nodal plane. So here y-axis and z-axis, there is no nodal, there is no lobe. So they are considered as nodal plane. Got it? So yz is the nodal plane. Now let us look into the next orientation, py. So py means the lobe will be seen on the y-axis. Lobe will be seen on the y-axis. So you can see this is x-axis, this is y-axis. So you can see the lobe, dumbbell-shaped lobe is seen on the y-axis. Got it? So what will be the nodal plane? So that is x and z is a nodal plane. Why is it called nodal plane? X-axis and z-axis, because on these two axes there is no lobes. Okay. So the axis where there is no lobes, they are considered as nodal plane. So x, z is the nodal plane. Now let us look at the next orientation, pz. Okay. pz. So pz means here the lobes, that is the dumbbell-shaped lobes are seen on the z-axis. Got it? So you can see this is z-axis, this is x-axis, y-axis and z-axis. So on the z-axis the lobes are seen. Okay, and on the x-axis and y-axis there is no lobes, so they are considered as a nodal plane xy. Got it? So this is the diagrammatic representation of the shape of the p orbital. So p orbital shape is always dumbbell. Okay, and there are three suborbitals. So p is the orbital and px, py, pz, they are called as the suborbitals. Got it? So px, py, pz, because they are having three orientations in the p orbital, corresponding to that three orientation only the suborbitals are there. So px, py, pz, they are the suborbitals. Got it? Yes. Now let us look into the d orbital. So d orbital, for d orbital the value of L is equal to 2. Okay, so the values of L you should study thoroughly. So for p orbital the value of L is equal to 1. For s orbital the value of L is equal to 0. Okay, so for p orbital value of L is equal to 1. Now for d orbital value of L is equal to 2. So when the L is equal to 2, then what will be the magnetic quantum number values? -1, -2, -1, 0, +1, +2. Okay, so there are 5 values here. -2, -1, 0, +1, +2. So likewise 5 values are there. That is the 5 orientation. So d orbitals are having 5 orientation. Now how these 5 orientations are represented? So they are represented as dxy, dyz, dzx, dx square minus y square and dz square. Got it? So the 5 orientation of the d orbitals are dxy, dyz, dzs, dx square minus y square and dz square. Okay, so here the d orbitals, they are having the shape of a clover leaf. Okay, they are having the shape of the clover leaves, and in this clover leaf you can see this is the clover leaf shape. Okay, so there are lobes, 4 lobes are there in the clover leaf, 4 lobes are there, and in the case of d orbitals there is 5 suborbitals. In the case of d orbital there are 5 suborbitals. How 5 suborbitals? Because there is 5 orientation. So this 5 orientation corresponds to the suborbitals of the d orbital. So these are the so here 3 shapes of the d suborbitals are there. So for dxy, so in the case of dxy, lobes are present in between x and x-axis and y-axis. Okay, understanding? So in the case of dxy, dxy's orbital, the lobes are present in between x and y. Whereas in the dyz orbital, the clover leaf lobes are seen in between y and z axis. Okay, and in the case of dzx orbital, the lobes are seen in between z axis and x axis. So it is very easy for you to draw the diagram. Yes, just to draw x axis and y axis, and you just draw the lobes in between the axis. Okay, in between, lobes are seen in between the axis. So which two axes? In this case, in the case of first orientation, that is dxy, so lobes are present in between x and y. Whereas in this case, lobes are present in between y axis and z axis. Okay, and in this case, lobes are present around or in between x axis and z axis. Okay, now let us see the fourth orbital of D. Okay, so the fourth orbital is dx square minus y square. Dx square minus y square. So here, in this case, the lobes are seen on the x-axis and y-axis. Okay, whereas in the other three lobes, that is the dxy orbital, dyz and dzx orbital, here lobes are seen, the four lobes are seen in between the planes, in between the axis. Got it? In between the axis. So whereas here, the lobes of the orbital, the dumbbell shape, the clover leaf shape lobes are seen, four lobes are seen on the x-axis and y-axis. Okay, so it's easy for us to remember here. Okay, so in this, the last two orbitals of the d orbital, they are seen on the axis, whereas the first three orbitals, they are not seen on the axis. Instead, they are seen in between the axis. Okay, that can be x-axis, y-axis and z-axis. Now looking to the fifth one, that is the dz square orbital. So in this case, on the z-axis, the lobes are seen. So along with these lobes in the center, that is the nodes. This is the nodes. Okay, this is the node. Okay, so in these nodes, there you can see a donut shape. Okay, so this type of donut shaped ring can be also seen here. So this is the shape of the dz square orbital. So likewise, the orbitals are having 5 orientation based on the value of n. So that 5 orientation shapes are given here. The first, second and third shapes of the d orbital, that is the clover leaf shapes. Yes, the lobes are present in between the x-axis, y-axis and z-axis, whereas the fourth and fifth shape of the d orbitals, they are present on the axis. Okay, they are present on the axis. Lobes are present on the axis. There are 3 nodal planes in the d orbital. How many nodal planes? 3 nodal planes on the d orbital. Okay, now to the f orbital. So for f orbital, the value of L is equal to 3. Okay, so when the value of L is equal to 3, then what will be the value of M? M will start from 3, minus 3. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, so these are the orientation. So 1, 2, 3, 4, 5, 6, 7 orientations are seen in the case of f orbitals. Okay, so because it is 7 orientation, the f orbitals are having 7 suborbitals. Okay, as f orbital is having 7 suborbitals. Okay, so what are those 7 suborbitals? Fz cube, fxz square, fxy square, fyz square, fxyz, fzx square minus y square, fx x square minus 3y square, fy 3x square minus y square. So these are the 7 suborbitals of the f orbitals. So drawing the structures of these suborbitals is very complicated and very confusing. So we need not go to it. We just study the names of the 7 orientation or the 7 suborbitals of the f orbitals. Fine. So that's it all about your shapes of the orbitals. Fine. So hope you understood. So all the shapes, p orbital, d orbital, s and f orbital. So p, s orbital, p orbital, d orbital, the shapes are very important. Whereas the f orbitals, you just study the 7 orientation or 7 suborbitals and how many three nodal planes, that's it. We need not go into the shape of the F orbitals. Okay, so just to study what is the orientation, 7 orientation, that's more than enough. Okay, so here in F orbital 3 nodal planes are there. Even in the D orbital also 3 nodal planes. Fine. So that's it all about the shape of the orbitals. Hope you understood. Thank you.